Hello and welcome to this video. In this chapter, we'll be learning about cubic graphs, quartic graphs, reciprocal graphs, finding points of intersection between graphs on x and y axis, translating graphs and stretching graphs, and transforming functions in general. So just a heads up, cubic curves or polynomials in general have their highest power as x to the power of 3. There may or may not be other terms with lower powers of x, for example, but the highest power of cubic will be x power 3. Quartic, as the word sounds like, it has the highest power with x power of 4. So we'll look into those graphs. Reciprocal graphs are when you plot y against 1 over x. So their graph in general looks something like so. We'll look into more details for that. Points of intersections we'll look into. And these two are rather related together. Translating graphs and stretching graphs. These are different transformations that will happen to graphs if you change certain variables, certain constants. For example, this a or b are factors that will. I don't want to ruin the surprise, but they will affect the. They're called the stretch factor. All right. So transformations. We look into more depth as we go into each chapter. All right, so as usual, I suggest you pause the video, you have a go at these questions. These are prior knowledge check. It's absolutely essential that you can answer these questions and show you the answers. So pause the video and have a go. All right, I hope you've had a go at these questions. To factorize 1a, what you notice is that that's b, so that's separate. We're just looking at these terms here. What we have in common, the numbers are not factorizable. 2, 7, and 15, they don't have anything in common with each other. But x is a common factor, so we can factor x out of them. What we'll get is 2x squared plus 7x minus 15. Then what you notice is that you have a quadratic here inside the bracket, which you can further factorize. Now, I've shown you many times how to do that. I'm not going to do it here. So it will factorize into these three factors. The quadratic that you should be able to factorize by now. If you can't, go and check my video on chapter 2 and I'll show you clearly quite in depth how to do it. It will factorize into these two factors. For sketching graphs in question 2a, you should be able to do this without a problem. The factorized form is given to you in this part A, in this example here. So one of the solutions is -2, the other solution is +3. That means that when you draw a smiley face here, one of the left root is -2 and the right root is a +3. And you do have to, when you sketch, you do have to show where is the y-intercept. You substitute x equals to 0 into this equation. Here you will be multiplying a +2 with a -3, which will give you a -6. So that's the y-intercept there. All right. So for the next question, you do have to factorize it first. So factors would be -7 and +1 inside the bracket. So when we take them outside the bracket, the roots will be +7 and -1. All right. So when you plot the graph, you check here there's no sign here, so a is a positive value. So 7 would be on the right and -1 would be on the left. To figure out the y-intercept, you substitute 0 into this equation and you'll get a -7. So this point here, y-intercept is -7. That 7 is the x value. This -7 is the y value. For this question 3 here, you do have to evaluate this expression, but there is a shortcut that you can put into your calculator. Use the table menu, the table function from your calculator. If you don't know how to do that, check out my other video where I'll show you. You have to basically just give it the steps of the lowest value of x is minus 3 over 2 and highest value of x is positive 3 over 2, and the x's go up by a step size of a half. So make sure it goes from minus 3 over 2 to positive 3 over 2 with the steps of a half for x. And once you type in this equation, your calculator will give you each of these missing values, and you can check the given values with it. So I'm going to simply show you the answers here. And finally, for question 4, it says solve these pairs of equations simultaneously, right? So I've gone into quite a bit of depth showing you how to solve simultaneous equations. You should be able to do them by now, but you can simply substitute 2x here. We'll have 3x equals to 6, so x equals to 2, and y equals to 4. That's not hard to do. And if you substitute x squared where y is, you subtract 2x and add 1 to both sides of the equation. You end up with this equation, which factorizes to two negative ones inside the bracket. So that's x minus 1 squared. So that's telling us that there's a repeated root at x equal to 1, and y value will be also a plus 1 as well, because, well, y is x squared. So there's a repeated root of 1, 1. Alright, I'll see you in the next video.